All right, welcome back for another episode of Con E352. Today we're going to be discussing air handlers and air handling equipment, the whole purpose of air handlers, choices for air handlers, what they do, and how large they are. All right, so for today's class, you're going to need the notes packet. We're starting on page 47. There's also two different handouts that I've put on Canvas. One of them is on indoor air handlers, and one of them is on filters. So it might help if you print those out. You might want to make a few notes along the way. But also, obviously, in addition to just watching the video, it'll probably be helpful if you take some time and kind of Google some of the images that I'm going to tell you to take a look at. And just because these, by the time, this has been printed and scanned again and put on Canvas, some of these pictures aren't the easiest to see, and they're not going to look all that great on the TV monitor here behind me. So it'll help if you Google some of these images and try to find them yourself so you can take a look at them. All right, so let's begin. Air handler basics. Important key component within a mechanical system is the air handler. The air handler is what conditions the air. And I don't mean just cools it, although that is typically what's thought of as an air conditioner. It is cooling and dehumidifying the air. It's also filtering it. And during some times of the year, it may be heating it. It is also mixing it with outside air and then giving it the fan energy to distribute it through the building. So the air handler has a lot of different purposes. All right. So starting on page 47, we look there, and the handout talks about the purpose: circulate air, bring in fresh air, exhaust air. Parts of an air handler. And this is where it gets a little bit difficult for those of you that are brand new to this particular industry. There are thousands and thousands more than that, different choices for an air handler, different manufacturers, different configurations, different equipment, and it varies with project size. It varies with project purpose. In other words, an air handler for a hospital is going to be different than an air handler for an office. A small air handler that is handling maybe a few thousand CFM for a couple of rooms is going to be very, very different from a large one meant to handle like a laboratory space. And I have designed both in my career. So the hard part is when you're starting out is there's so many options. It's hard to get a handle on, well, what's really required. And so what I'm going to try to do is focus on what I think are the basics. And then in industry, you might see a bunch of other stuff added to it. But just know that let's just focus on the basics as a learning point. Basic parts. You got to have a supply fan. The supply fan is what's going to push that air down the ductwork and into each room. Right? So a supply fan is a key component. A cooling coil, another key component. Cooling coil is going to be what removes energy from that air. Remember, we calculated this in the first part of this class. We calculated, well, what is the cooling load? Well, physically, something has to cool that air down and dehumidify it, and that's the cooling coil. It can either be chilled water, where we take a chiller that's rejecting heat to the outside to make water cold that we pump around the building, or it could be what's referred to as DX, direct expansion. In other words, we skip the pumping of the cold water part, and we just take refrigerant and cool the air directly. The smaller systems are usually going to be the DX ones. Not always, but that's, in general, the smaller is going to be the refrigerant-filled coils. We're also going to have heating coil. Could be electric, could be steam like here on campus at Iowa State, could be hot water. Whatever it is, some hot source that's going to warm the air up, because we might find ourselves during the time of the year when it's so cold outside, just bringing in enough air for ventilation is going to take that mixed air and make it very, very cold. So we're going to have some way of adding heat to it. Next item, filters. Filters are one of the more simple maintenance items in HVAC systems, and yet one of the most important. Filters make sure that the rest of the stuff is working properly. I mean, if we're passing air through a cooling coil, passing air through ductwork, passing air through fans, any dust, dirt, contaminants, who knows, leaves, small bugs, cottonwood seeds, whatever it is, anything that gets in there is going to at least degrade the performance of those other items, and at worst cause mold and other organic bacteria to grow. So filters are very important. They are very simple, and they are often neglected because it's easy to ignore them. Then a mixing box. Remember on the diagram where I drew a picture of the building and I show the outside air, exhaust air, supply air, and return air. That box where all that happens is called the mixing box, where we take return air, we exhaust some of it, we bring in some fresh air from the outside, and we get our mixed air. And then a return fan. Not required on every air handler, but I'm going to include it in my discussion because on any large air handler, you're going to have a return air fan. The only way to truly control the pressure of a building is by using a return air fan. And we want the building pressure to be controlled for the reasons we talked about earlier in the class, because with the wrong pressure in a building, we're going to pull air in where we don't want it to, and that's around the doors, the windows. Here lately, I don't know if you've noticed this, but if you walk into one of the doors in Town Engineering, as you open that outside door, before you get to the second door, you'll hear the ceiling tiles lift up. That's not supposed to be happening. That, in engineering terms, is bad. That means we are exhausting more air out of the building than we are bringing in at the air handler, and we're making our building negative, which is a bad thing. Usually, most years, Town Engineering and Black Engineering have a competition to see which building can suck leaves in the fall the furthest into the building. Town Engineering is usually good to sucking leaves in at least to the second floor stairwell. All right. Most years, Black Engineering, though, beats us, and they're able to pull leaves maybe second floor, maybe even third or fourth floor. Both of those are bad, or rather, I should say, they are a good example of a bad way to operate a building. All right, we're going to talk a little bit more about return fans and their purpose later on in this lecture. Sound attenuators. Sound attenuators, not required on every air handler, frequently done when we are worried about noise that a fan air handler, or the fan for an air handler, generates. Once again, good example of a bad example. Go to Town Engineering if you're one of the classrooms. Maybe if you get to a room first and there's not a lot of noise, you'll easily be able to hear like a low frequency rumble. That is fan noise that travels down the ductwork and into each room. High levels of that can be very objectionable, and a sound attenuator, like I said, while not required all the time, is a good way to attenuate that noise. Now, cooling coil size. Always size the cooling coil based on the psych chart. We've already discussed this. We have to have both the latent and the sensible energy removed from that airstream. So that requires a psych chart, and that requires a cooling coil calculation. The supply air CFM, once again, review from previous in this class, supply air CFM is based on space sensible load. Space sensible. Remember the 1.08 CFM delta T, where the Q is the space total sensible load, and that's how we size the supply air quantity, and therefore the supply air fan. The physical, I'm not talking about the capacity size, but the physical size of the cooling coil is usually the limiting size on the cross-sectional area for an air handler. Normally, we don't want the air going through a cooling coil to be going faster than about 500 feet per minute. Any faster than that, and the condensation that forms on that face of that cooling coil is going to get pulled along through the ductwork. So that's going to make our coil section pretty large, and that's going to be what drives the physical dimensions of our air handler. And at the end of this lecture, we're going to go through a calculation on how to figure out the physical dimensions of the air handler, which I want you to do for your final project. Now, supply fan size. There's just this simple calculation to get the fan horsepower. Fan horsepower. You take the CFM of the CFM of the air handler, multiply it by the static pressure in inches of water. Inches of water. Ideally, everybody's taken fluids and understand what that means, inches of water pressure. If you don't, please look it up or review. But the pressure is in inches of water. And then we multiply that by a constant, that 0.000157. That gets all of our units to work out. The product of all this is in horsepower. But we're going to take cubic feet per minute times inches of static pressure times 0.00157 and then divide that by the efficiency of the fan. How to calculate fan efficiency is beyond the scope of this class. I just give it to you. Fan efficiency is usually between 55% and 75% for the larger fans, and that means greater than 5 horsepower. Fan efficiency is how well does that fan do at taking input energy, the electric energy of the motor, and turning it into flow energy that forces air down ductwork. That's how we're going to define fan efficiency. All right. Okay. Heating coil size. At a minimum, we want to size the heating coil so that we raise the CFM of outside air from our outside design temperature up to 55 degrees Fahrenheit. And the reason I use 55 degrees Fahrenheit is year-round, the temperature of the supplier coming out of the air handler needs to be at 55 degrees. That doesn't change from winter to summer, and here's why. In a large building, like a large office building, large school building, once you get more than 15 feet away from the exterior wall, the rest of that building does not know it's winter. In other words, an interior space does not have any outside walls or windows or roof to lose energy to. So the interior loads like people and computers and lights will always cause the space to heat up. Therefore, we will always need air conditioning. Year-round, we're always going to need air conditioning in some of the spaces. So the output of the air handler needs to be 55 degrees Fahrenheit. When we need heat added to a room, that's the purpose of that reheat coil at the terminal air box. All right. So when we're sizing the heating coil capacity, it's take however many CFM outside air that we need, raise that from our outside design temperature, usually minus 20, up to 55 degree air. All right, let's talk a little bit about the return air fan. Okay. Return air fan pulls air back from the space, forces it back through the return air ductwork. Some of it gets forced out of the building through exhaust air dampers, and then the rest of it goes through the fan, or I'm sorry, through the filters. The return air fan, for this class, remember I told you the supply air CFM is equal to the return air CFM. On a real building, we're going to use the return air fan to control the building pressure, and the way we do that is by returning slightly less return air than we have in supply air. This means that some of that air that's supplied has to go out through the building envelope, and then that is what's going to positively pressurize our building. All right, keep on going. Filters. Filter efficiency is defined by ASHRAE Standard 52, and it comes up with a MERV rating. Let's pause here, and I want you to take a look at this particular handout on filters. Right? it'll say like allergy clean environments. And like I said, by the time I've copied and copied and copied this and scanned it, it doesn't look very good. But I've got some, we'll be able to Google some of the important stuff. But understanding MERV, or the minimum efficiency reporting value. How do we rate filters for air handlers? Years ago, we used to do it just based on what we would call efficiency, fan efficiency. That's a 30% filter, that's a 60% filter. And what they would do is, to test this, they'd have a certain quantity of dust, and they weighed that dust, put it through a filter, and then weighed the dust afterwards. And however much the filter caught was the percentage of efficiency. That was a terrible way to rate efficiency. It really doesn't tell you how good that filter is at removing particles of various sizes. And that's what the MERV rating tells us. If you scroll down here to the second page in the handout, it gives you a bunch of particle size, anywhere from 10 microns all the way down to 0.3 microns. And what this does is, as they run that through the filter, they'll weigh the particles at each size, and it comes up with an efficiency rating. And it's just a MERV value of 1, 2, 3, 4, whatever that is. And when you go to purchase a new filter, we're going to purchase them based on their MERV rating. I don't need you to know all these numbers and microns and sizes and groups of particles. What I do need you to know is this next page, where it has MERV rating. Kind of ignore efficiency. If you found like an old filter, that's kind of what that would be compared to. And then what I really want you to know is the purpose and type over here. All right, MERV rating of 1 to 4. Think like residential. The metal ones, or the plastic or foam ones that you could wash, not very good. Doesn't really do a great... It'll stop particles of greater than 10 microns. But anything smaller than that is probably going to get right through it. I would probably call a MERV rating of 1 to 4 a poor residential one. A decent residential, and maybe even a light commercial one, would be a MERV rating of 5 through 8. Now we're getting a better efficiency at particle sizes of down to 3 microns, and that would be good enough for, like I said, residential and some light commercial applications. Light commercial being office spaces and areas that we're not producing a lot of dust and dirt, and moving dust and dirt around is not that big of a deal. Let's get to a better one. MERV rating of 9 to 12. That's the ones that I would think that would be kind of like your starting commercial filter. They're going to be the pleated ones. Like in a box that they're pleated. Maybe they've had some adhesive, they call a tackified agent, put on there to help grab that dust and dirt. You might also see like rigid cell filters or bag filters. I've got examples of each of those here in a little bit. MERV rating of 13 to 16. That's where we get more and more efficient, and also more expensive and larger. When you're getting in a MERV rating of those, you could either do, that's like high-end commercial applications. You'll also see it for surgery, hospitals, healthcare, communications applications. Those are probably the top ones that you're going to see most of the time. And then beyond that, there's actually even better filters. They are called a HEPA filter, high efficiency particulate air filter. And I've got examples here of each. Now, the handout has pictures, but the only reason I gave you this is so that you see this model number here. It says Purolator F312. I want you just to pause here and just Google what a Purolator F312 is. All right. And that's where these images come from. So I Google-ade the Purolator F312, and I want you to take a look at it. This is sometimes called a construction filter. Notice this one, if you look at the handout, and there's another reason I gave you this handout, is that I want you to look at the size and the price. All right, size and price. I looked up on, this was on just a Global Industries filter sales site. I looked up a 12-inch by 12-inch, so a 1 square foot filter, this Purolator 312. It doesn't even have a MERV rating. It's 1 inch thick. It is disposable, all right, but it's not pleated. And notice the price. For 12 of these, the price is $1.20. They are 10 cents per square foot. Just remember that. And these prices are kind of old, but for comparison purposes, they still work pretty well. Sometimes contractors, when they say, hey, we want to run the air filters, at least run them during construction as temporary heating and cooling, and will protect the ductwork with these construction filters. Warning, not advised. In my professional opinion, that should never be done. These with a MERV rating, well, they don't have a MERV rating. These particular filters will stop decent-sized insects, birds, Snicker bar wrappers, and not much else. If you're still in construction and you're generating dust, especially drywall dust, this filter won't even stop drywall dust. It'll just go right on past it. These are best used as a pre-filter or not at all. They're kind of junk. They're not even a good residential filter. And notice 10 cents a square foot makes them cheap, and in filters, you get what you pay for. These are junk. All right, moving on. Let's look at a slightly better filter. On your handout, the Purolator FMEX 40, medium efficiency. This has a MERV value of 8. Remember when I said this is like what I would consider the starting point for commercial filters? Notice this one is pleated. Here, check out the picture. You'll see within the filter itself, the face of the filter, it is pleated. Here's a cutaway version. Notice it's pleated, and it also has wire on it. That wire helps it hold its shape. The reason it's pleated like this is that the way to filter air is to put more filter material in the airstream and then slow that air down. By pleating it like that, you're giving it more surface area to grab the particles as they pass through. So these pleated ones increase the efficiency. The wire frame holds it in place, and by using a good media, that's the actual material there that's in the pleats, that'll help us grab more and more and more dirt and dust and particles. Something important to notice on every filter that we have. The better it is at filtering the air, the more pressure loss that you're going to experience, the more fan energy that it's going to take to force the air through there at the appropriate velocity. There is no getting around this. Better filters have more pressure loss and therefore use more fan energy as it does it. There's no shortcut to that particular formula. All right. So these are MERV 8 filters. Pretty good. But notice the price. For a 12-inch by 12-inch size, that's 1 square foot of filter on MERV 8, we can buy 6 of them for almost $6. So the cheap blue ones were 10 cents a square foot, and now these are more like $1 a square foot. Order of magnitude, 10 times more expensive. All right, but let's keep on going. Let's go to an even better filter, right? Once again, if we look at the Purolator Dominator high efficiency filter. All right, I've got a couple of different ones. First, this is, before the Dominator, this is a bag filter, different type. This is just a different orientation. Notice this one. Instead of pleated media that's only an inch or two thick, this bag, this could be like 2 feet deep. The air comes in the pleats and goes through it, increasing the surface area for our filters. Something important to notice here. 1, these get more expensive because there's just physically more media that we're purchasing. 2, in the air handler itself, whereas that pleated filter only takes up 2 inches of thickness, this is going to take like a foot or 2. So it makes our overall air handler much longer and also more expensive and takes up more space. Whether you put that air handler inside in a mechanical room or on the roof, it just got bigger and therefore more expensive. But these bag filters will have less pressure drop and you won't have to replace them as frequently as you will the pleated ones. All right, now let's go to the Purolator Dominator high efficiency. Oh, and I almost forgot. I'm sorry. The cut sheet on this one, that Purolator Servapack bag filter, for a MERV 11. So MERV 11, we're getting up there in efficiency. A really, really good commercial one, maybe low end for a hospital or something along those lines. For 8 12-inch by 12-inch filters, and the 12 by 12, that's the face area, right? For 8 of them, it's $24. So now that we're at $3 a square foot of filter, obviously quite a bit more expensive. All right, now let's look at the Purolator Dominator high efficiency filter. Now these are like MERV 15. Okay, once again, take a look. These are a cartridge. Like there's going to be a rack of them, and maintenance workers are going to, from the face of them, set them in the rack. They're a more rigid material. And notice these that I looked up, that they are 2 square feet of filter area. But look at the MERV 15 filters here. These are $40 each. Oh, I'm sorry. No, not $40 each. They're $80 each, but there's 2 square feet. So it's $40 per square foot of filter area. Yikes. These are really getting expensive. But if you need something like smoke control, like smoke filtering, or a clean room, or if we're talking about an operating suite or an isolation room, this might be the type of filter that you need. Notice, you don't want this filter filtering out normal just dust and dirt. And very frequently, before you have your $40 a square foot filter, maybe upstream of that, you might have something like this or something like this as a pre-filter before you get to your really super expensive high-end filter. But like I said, probably getting into healthcare applications. All right, speaking of healthcare applications, let's go to the next one. High efficiency particulate air filter. HEPA filtration. A HEPA filter grabs everything. All right? And I know maybe not everything. If you look at the actual efficiency of these things, it's like 99.9999% efficient. Let's just go ahead and call that everything. The Ultracell HEPA filter is 99.97% efficient at a 0.3 micron size. We are getting down to the germ and bacteria level. Where would I need a HEPA filter? All right, I might need a HEPA filter if I was in a hospital. If you're doing, say, open heart surgery And this is a life and death type of thing. The air that goes into that room and goes right on the patient, HEPA filters. If you have like a tuberculosis isolation unit in a hospital, HEPA filters on the outlet. Captures everything. Here in recent times, obviously we've learned how important germ control is. You might need HEPA filters for isolation rooms for highly contagious diseases, highly contagious and potentially deadly. And definitely in labs where we're doing experiments on diseases like that, also known as a biosafety level room, we're going to have very, very, very high levels of filtration, probably HEPA filters. In my career, I've only designed one room like that for the State of Iowa Hygienics Lab. They had HEPA filters on all the air coming into that lab and all the air leaving that lab. Grabs absolutely positively everything down to the germ level. But if you're dealing with infectious and deadly germs, it's the type of thing that you need. Notice though, if we go to the cut sheet, look at the price for one of these. All right. Here, if we go to go all the way to the HEPA filter. It is located right there underneath our price for one of them. And this is, now notice, this is a 2 foot by 2 foot. So there's 4 square feet of filter area. However, the price is $210 each for 4 square feet of filter area. That is a very, very, very expensive filter. And it also comes with quite a bit of pressure loss as well for the fan to force air through it. So, way to capture more dust and dirt. You slow the air down as much as possible and give it as much filter media, as high quality media as you can to catch and capture the particles. All right. Let's go back to the handout. Now, let's save ductwork for later. All right. We're going to have a discussion on the ductwork part a little bit later in the semester. And the reason I put the ductwork discussion off to later, what I've realized is if I have this too early, when we get to the final project, people forget it and I have to go over it again. So I've been saving the ductwork part for right at the end of the semester because that's when you need it. You're going to size the ductwork last after everything else. So we're going to come back to this requirement, or to the ductwork sizing criteria. ASHRAE standards, important ones. ASHRAE standard 62, that's the outside air requirements. ASHRAE standard 52, that's the MERV ratings. All right, and these on the filtration, this is just kind of a summary of the stuff that I just went over. Now let's look at air handlers and kind of schematic. So from a side view, all right, as we're looking at this diagram, return air comes in here to the return air fan. It goes through the economizer. The purpose of the economizer, which I believe we've touched on before, but I want to review it again. The purpose of the economizer is this is where we are going to mix this air, but also when it's cool outside, I can bring in outside air that's cooler than the space and use that for air conditioning. Remember, on most buildings, I'm going to need air conditioning year round. But if it's cool outside, why pay to run your air conditioning, your refrigeration cycle? Let's just bring in cool air from the outside that's free and bring that in. And that's an economizer. It's large enough that these dampers are big enough not just for the outside air minimum requirements, they're large enough to do 100% of the supply air quantity if we need it and if it's cool enough outside to make it worth it. All right, so the economizer does the mixing and has the ability to bring in free cold air from outside. Then we go to the filter. We just went over the different options for filters. You know, the rack filters, the cartridge filters, bag filters, HEPA filters, whatever that filtration is. Right? Then we go to a heating coil. We go to a cooling coil. The heating coil heats it. If we're bringing a bunch of cold outside air and this temperature is less than 55, we're going to heat that air up. And then we're going to cool it down here at the cooling coil. Notice the drain pan below it so that we can get rid of that condensate. And then a supply air fan that blows air down the ductwork and back to the space. And we go round and round and round with this. Now, and here's the equation for fan power again, right? What I want to do is take a look at the handout I just gave you. Oh, and there was one filter that I forgot to mention that you might run into when talking about HEPA filters. One filter that you might run into that you, as a general contractor, is the filter for shop vacs. A normal shop vac filter, right? You might be able to get, for $5, $10, something along those lines. We can actually find HEPA filters. This just happens to be Rigid, Rigid being the tool manufacturing company. You can buy a HEPA filter for a Rigid shop vac for $34 each. Where would you need this as a general contractor? Well, if you're working on an occupied building, if you're trying to do some remodeling and some work, you've got to maybe saw some boards, you've got to sand some drywall, something along those lines, and you need to control dust and dirt. This becomes a very critical item. You might need to purchase HEPA filters for your shop vacs. They do make them. Almost every vendor will have their own version of the HEPA filter, but just keep in mind, if a normal shop vac filter is like $5 or less, a HEPA filter $35 or maybe more. They do exist, might be an option, but it's going to be fairly expensive. All right, let's just take a look at, and what I did is I put together a few pictures of air handlers. What makes this difficult is in the field, if you just see an air handler, all you see is a gray box like this. It really, you have no idea what's going on inside of this. I mean, it might have some connections on the side where we hook up chilled water or heating water or steam or something along those lines. But it's hard to know what's going on inside of it. And this is where things get difficult, is that there's so many possible configurations, it's really hard to know what's going on inside of it. Here's a simple, small one with the side removed. Here's a supply fan blowing upwards with a motor and a belt drive. Upstream of that, we've got some heating and cooling coils and then just a filter section. This is a very small one, very simple. It doesn't have the mixing box. It doesn't have a return air fan, but it has some of the, what I would call the basics. Heating and cooling coils, filters, and a fan. That's as basic as it gets. Here's something a little more complicated, where we have return fan, right? This is, notice dampers on the top and here. That means this is the mixing box section where we also have an economizer. We would have ductwork attaching to those dampers on the top to send some air outside and bring some inside. Then we've got, like, this is a filter and mixing section. Allows the outside air and return air to mix around to get a uniform temperature before it hits the heating coil and cooling coil. Now here's the supply air fan. And on this one, this particular unit, this downstream is a sound attenuator. Remember, not all air handlers will have a sound attenuator, but an important thing here is this adds a lot of length to the overall air handler. Sound attenuators take up a bunch of space. And then from the outlet, we have where they take taps off of in all directions for air to go down the ductwork. Remember what I said about the overall dimensions. The height and the depth of this is going to be determined by the velocity limitation, that 500 feet per minute across the cooling coil, to prevent water drops from going on down that air handler and ultimately down the ductwork. Now I've got a picture here of a schematic of an air handler, and it's doing the same thing. It's just this one is a stacked one with two fans. So we've got the return air coming back through the exhaust and return air fan. It's called both because it pulls air into the air handler, that's the return air, and then it pushes it over here, it pushes it out these dampers for exhaust. Some of that air is exhausted, some of it is returned, mixed with outside air. There's our mixed air section. And now we go through a pre-filter and final filter. Pre-filter and final filter. Like I said, if we have a really expensive final filter, we want something that's cheaper upstream of that. Then we get into a cooling coil, a heating coil, right? A fan, and sometimes we will have a reheat coil. I don't discuss the reheat coil, but a reheat coil might be used if we had to really carefully control humidity. I might have to drop the temperature of this air down far below 55 degrees. Well, if we do that, that's going to dry that air out, but I might not want condensation within the space itself, so I'm going to reheat it here. I don't want you to include a reheat coil on your air handler for your final project. This particular diagram had one. Here's another thing that you're not going to see on most of them, a humidifier. Humidifier. As we discussed in psychrometrics, humidity should be added to a building cautiously. I'm very, very, very cautious about adding humidity to a building in the winter because of the risk of condensation. Most buildings will not have a humidifier section on them. Even older buildings that were built with one, most of them have been disabled just because of the problems humidifiers can cause in a building. So just know, the humidifier section, very optional. Sound attenuator, also very optional. But notice this, with all of these accessories, the reason they have this one kind of in a stacked situation is that this would get incredibly long if we added all the accessories like humidifiers, sound attenuators, reheat coils. That gets to be a very, very, very lengthy air handler. All right, let's go to the handout on air handlers now. Okay, indoor air handlers, right? Your handout from Daikin. Now, little plug here. Most of the data that I have comes from Daikin air handlers. Daikin is just one of many different manufacturers. There's Trane, there's York, there's Climate Master. I mean, there's dozens and dozens and dozens of air handling manufacturers. I kind of like Daikin, their website. I think it's easiest to find information. But even if you go to the Daikin website, you will find just tons of accessories and different sizes and different systems and different options. Here, at a glance, looking at Daikin applied products, we've got the small, they're basically just a coil and a fan. That's why they're called blower coils. They only go up to about 5,000 CFM. We've got our commercial air handlers. Think of these as like factory, off the shelf. You don't get a whole lot of options, and they go up to about 15,000 CFM for indoor air applications. Now, see this where it says semi-custom indoor air handlers up to 100,000 CFM. Semi-custom means I can customize it a little bit. I can get some options, all right? I can get some options to it, a little bit more than I would the off-the-shelf stuff for the Destiny model, but the Vision, it's not completely custom, and then I can't change everything about it, but I've got more options. Here, this Rebel commercial outdoor chilled water air handler. So it's meant to be outside, like up on a roof somewhere. It still is getting chilled water from a chiller somewhere. That means there isn't a refrigeration cycle within this air handler. It's not a packaged unit that comes all complete. I've still got to pipe chilled water to it. And this one's smaller, lot fewer options, and it goes up to 11,000 CFM. Bottom left, we have the Skyline semi-custom outdoor air handler up to 65,000 CFM. Semi-custom, more options. A roof pack semi-custom outdoor air handler, just different configurations and different options. And then this one is an indoor completely custom air handler up to 129,000 CFM. Notice this one, they just happen to show one that's a stacked model, kind of like that schematic that we just looked at. This is completely customizable. I could put energy recovery units, sound attenuators, as many coils as I want. I can make this do anything, but like with anything that's customizable, it comes with a cost. All right, so let's just take a look at the handout, and I scan this one. This also comes from Daikin, all right, and this is for the Vision air handler up to 100,000 CFM. Note, everybody remember this, for your final project, if you need one large air handler that is larger than the options that are within this catalog, this handout, great. There are options to get it. You just have to go to this spot, the DaikinApplied.com. All right, that's the website, DaikinApplied.com. Products, air handlers. And then once you go to this, you can click on like the custom air handlers and get product information, right? And now you can actually get brochures and manuals on it, engineering, performance data, right? This is where you would go to get data on one of these. And these can be as large as, well, at least as large as Daikin makes. Okay. All right. Let's go back to the handout for the Vision ones. I just want you to take a look at, this first thing. It lists all the options that you can get. All right. It just shows you, some of the things that you can get. Here we go. Widths up to 142 inches wide, right? Or I'm sorry, variable widths up to 228 inches wide in 4-inch increments. Heights up to 122 inches. So you can get one of these that's just over 10 feet high, just under 20 feet wide, and of any length that you want to purchase. That's a pretty large air handler, right? And then this picture, it's, like I said, kind of hard to see, but you can see somebody standing next to it, and he's not quite half the height of that particular air handler. All right, I'll let you read through the pictures, just looking at, now, here we go. Customizable options. These are all the different parts that you can pick. You don't have to pick all of them, but an engineer can pick and choose which of these that they want. And what I'm going to do is I'm going to walk you through the choices that I want you to make. All right, that's what this last table is. This represents all of the choices, all of our options, and our links. Notice, here we go. When you're picking your air handler, the limiting factor is going to be this line right here. Cooling coil face area in square feet. All right. And then below that, or I'm sorry, above it, see where it says CFM at 500 feet per minute through the large face area coil. that is going to be the limitation on how many supplier CFM that particular air handler can provide. Notice, if we look along this top line where it says unit size and CFM range, the airflow range, it can go up to 65,000 CFM, the unit size 090. However, the 65,000 CFM is not for air conditioning. The limit for air conditioning is right here, and a size 090, the maximum CFM is 41,000 CFM. If you need more than 41,000 CFM out of your air handler, many of you on your final project will, you need to find the air handler data for a bigger size of air handler. That's why I want you to know this particular website for the custom air handlers at Dakin Applied. You're going to need to come back to this if you need a larger air handler. So make sure, I know it's a long time until you're picking air handlers for your final project, but just make sure to note that someplace in your notes, remember it, and come back to it. Here's how we get the overall length of the air handler. So first, we get the height and the width. We're just going to use a 40,000 CFM air handler, and it tells us the height is 110 inches high and the width is 136 inches wide. So that fixes the height and the width of the air handler. Just under 10 feet high, just under 12 feet wide. And here, if you go to this on the air handler example, notice I've already shown you, I've given you a blank one of these, and these dimensions are blank. What we're going to do is we're going to pick these individual parts and we're going to look up the widths on that handout. So let me just, for you to label the various parts, this is a return air fan. This is an economizer section, the whole thing here. This is a filter section. This is a heating coil. This is an access section. This is a cooling coil, and this is a supply fan section. That is the minimum parts that I want you to have. The height of it, we've already determined. The depth of it, like into the board, we've already determined. We just need to add up the items to get our sizes. And that's what this handout is for. So get ready to circle and highlight, because I'm going to tell you the things that I want you to use. All right, so let's look at fans. You have the supply fan, you have the return fan. If we're starting from the left end of that schematic, we'll start with the return fan. For the return fan, I want you to use this. The largest belt drive plenum fan and motor available. All right, that just tells you what the manufacturer is telling you is it won't be any bigger than this. So for a 40,000 CFM air handler, if I'm using a belt drive plenum fan, and you don't have to understand why, just trust me that that's what we're going to use. It's that type of fan. That length is 82 inches. So back on our handout here, this first depth length here would be 82 inches. All right. Also, let's take a look at the supply fan. Rather than a plenum fan for the supply fan, we're going to use a largest housed fan and motor available with top horizontal discharge. All right. Once again, which fan we pick is kind of beyond the scope of this class. Just know, okay, it is a 92-inch long fan section. So once again, back here for this, we already looked up the return fan, the supply fan, 92 inches. All right, back to the next piece of this. What other items are we going to have in here? Well, let's look at economizer. There's only one line. There's no options here. The economizer for a 40,000 CFM air handler is 112 inches long. So back on this, we'd have this economizer section be 112 inches. All right. After that, we have the filter section. Well, which filter section should we use for this? And that's where we list a whole bunch of different choices. We've got flat filters, angled filters, cartridge filters, bag filters, right? Now, the first ones of these are side load. Side load is where you slide it in from like the side of the unit. But for something as big as this, that's a long way to push filters through. We probably want a front load filter. And take a look at this. A cartridge filter is 12 inches deep with a 2-inch pre-filter, right? Or a bag filter, which is even longer, 36 inches deep with a 2-inch pre-filter. Now, that ends up being, for a cartridge filter, 16 inches deep, or for the bag filter, 40 inches. Let's go back to our schematic. Most of the time, well, if space is at a premium, and it almost always is, you'll probably use the cartridge filter right here. So put in the cartridge filter with the pre-filter option, which is for the front load unit, that is 16 inches long. All right. So we've got our 16 inches of depth for this thing. And then now we come to our next item, which is a heating coil. There aren't a lot of options for the heating coil, which makes this easy. If we go to the heating coil section, right, there's coil sections. Heating only, 2-row water, 12 inches deep. That's it. That's our only choice. It's going to be 12 inches deep. And the reason is that we can get about any temperature range that we want off of a 2-row heating coil using boiler water. So we don't need a whole lot of options. Now, next one. Cooling only. Cooling only with 4-row, cooling only with 6-row. I always pick the bigger one. So our cooling coil is going to be 24 inches deep. So once again, back to the schematic. Here's the heating coil. Here's the cooling coil. Put those dimensions in I just gave you. But notice there is a space in between those two. The space in between those two is an access section that you should leave in the air handler. We don't always leave them because it takes up space and it makes it expensive, but if we're ever going to do real maintenance, and that is clean these cooling coils and heating coils, we've got to access both sides of each coil. Well, I can take out the filters and clean this side of the heating coil, and I can get in here to the fan section and clean this side of the cooling coil. But in between there, if they were mounted flush together, you wouldn't be able to get in there. So we need an access section in between there, and if we go to our sheet, we will find an access section. We can buy them anywhere from 16 inches down to 54 inches. Now, here's the question. How wide of an access section do we need? Well, really, this is a function of what's got to happen in here. A maintenance worker has to bring a power washer, tools, scrubbers, whatever, in here and do some work. How much space do we need in there for our maintenance worker to work? I'm going to suggest at least give them 3 foot of space to do any work in there. Anything less than that gets really difficult. It's possible, but it makes it kind of difficult. So give them some space in there. All right, so now, once you've got all of those filled out, we can get the overall length for that air handler. And I want to say in the example that I did, if we've done this right, it ends up being 30 some odd feet long. That is a really long section of air handler. I want you to do it though, right? So put all those in, add it up, and this is the process. Now notice, if you look at this handout, most of you will need an air handler bigger than 40,000 CFM. I did this on purpose. I did an example for a smaller size, knowing you're probably going to have to find the cut section and do this same exercise for a larger air handler. right? So just remember that part when it comes time for you to pick an air handler, and then get the size, because for your final project, you have to show me the physical size of your air handler and where you put it in your building. Okay, let's go back here. All right. In the handouts, I've got a bunch of different pictures of air handlers. The thing is, notice, they all look like galvanized steel boxes. It's really hard to see very much from these, but I put some small ones, some larger ones. This is a specialized one for a computer room unit. This is a raised floor. The return air comes through the floor. It cools it in here, and then see this ductwork in the ceiling. I'm sorry, I said that wrong. The return air path is in the ceiling, and then it supplies it at the floor. So cold air comes in the floor, and then it goes up at each server room. And this would be for like a monstrous computer room, server room kind of thing. And let me say, just remember, the supply air goes through the floor. That's where the cold air is. And the warmer return air comes through the ceiling. Okay. All right. Next week, we're gonna get into system selection, looking at different systems, kind of go through some examples, hopefully, and go from there. So system selection next week. I realize we are just a shade behind compared to the syllabus, right? But we're going to be able to make it up before that next exam. So the system, let's see here. All right. Systems exam is in a couple weeks. So next week, we'll go through system selection, energy code stuff, and let me think here. Yeah. System selection and energy code will be all next week, and probably get into it a little bit even the week after. And then 2 weeks from yesterday, which will be on the 15th of October, that's when we'll have our systems exam. Once again, multiple choice, right? So I'm going to encourage you to stay up on your videos, and I will catch you all next week.